What's going on, guys? In this video we are going to see how to prove this proposition. Here this proposition says for all x comma y belongs to integer, if xy is even, then x is even or y is even. Now let's see how to prove this one. To prove this one, first what we are going to do is we are going to see the opposite case is true. Like for example, if we say xy is odd, then x is odd and y is odd. If we can prove that one, it means the opposite also like true, because if xy is odd and x is odd, y is odd, then if xy is even, x must be even and y must be even. Now let's see whether we can prove the opposite case. Now let's go ahead and do that. First, proof. So here we know that xy belongs to integer, so we are going to say let xy belongs to integer, and we are going to say assume x is not even, x is not even. This is called contraposition. Like we negate this one and write it as opposite. Like after if we are going to say x is odd, y is odd, and we put x. If x is odd, y is odd, then xy is odd. X is odd, or we can say x is not even, and y is not even, then x is odd and y is odd. X is odd and y is odd. Okay, now let's go ahead and prove this one. First, what we are going to say, that let, okay, we have done xy belongs to z, and also we are going to say let a belongs to an integer with x is equal to 2a plus 1. 2a plus 1 mean if you multiply an integer by 2, that's going to be even, but if you add 1 to that, that's going to become odd. So we are saying x is odd in mathematical expression. And also we are going to say y is odd. To do that, I'm going to introduce another variable, that's b, and let b belongs to integer with y is equal to 2b plus 1, and then we are going to introduce another variable, put c is equal to 2ab plus a plus b. Now we want to prove xy also odd, so I'm going to multiply x and y, and we know that x is equal to 2a plus 1. I put that one right here, 2a plus 1, and then y is equal to 2b plus 1. I put that right here, 2b plus 1, and if we multiply these two, that's going to give us 4ab plus 2a plus 2b plus 1. Here you can see we can take 2 common for the first 3. If we take this, is going to become 2 times 2ab plus a plus b, and then here we have 1 left. We put it outside, and I brought in this pattern because you can see we equate c to this term. So instead of this one, we can replace that one with c. So 2c plus 1. Okay, 2c plus 1 mean odd, because we are multiplying an integer by 2, that's even. If you add 1 to that, that's odd. So we proved xy is odd. So we can say this means xy is odd. Thus xy is not even. Then at the end we are going to say therefore if x is not even and y is not even, then xy is not even. If x is not even and y is not even, then xy is not even. So finally we can conclude this one as, okay, let's get rid of these things. Okay, let's write it right here. Therefore if xy is even, then 'x' is even, then 'y' is 'y' is 'y', then 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 'y' is ' or y is even. Okay, that's what we want to prove. That's our proposition. Okay, I hope you guys find this video helpful. Thanks for watching, and if you're trying to learn discrete mathematics, there are a bunch of videos in my playlist. I hope you guys watch that too, and don't forget to subscribe. See you next time.